Assalamualaikum and hi, good evening. Today I would like to present about free body diagram representation from actual structure. So this is our group member. My name is Wan Muhammad Akmal Azrai bin Wan Nazli. My number matrix is B0922102112. Secondly, our members is Muhammad Anik Lokman bin Muhammad Salahuddin, B0922100044. And the last, Muhammad Ifanuddin bin Zainuddin bin B0922100009. So this is our objective for our present, to draw a free body diagram of a structure that we have choose to determine the force acting at the joint and support of the structure. And then this is a basic theory we do at for calculate Fx equal to 0, Fy equal to 0, moment equal to 0. So and then this is question number 1. A design model for a transmission line tower is shown in the figure. Members GH, FG, OP, and NO are selected cable. All other members are still bar for the loading show. Compute the force in member KL, PQ, FH, EJ, and DS. Use a combination of method if desired. So this is question to find the members, 5 members there. So this is uh full free body diagram for question number 1, and then EOE Fx equal to 0, X minus Ux equal to 0, X equal Ux, and then Fy equal to 0, X plus Uy minus 25 kilonewton, minus 25 kilonewton, and equal to 0. So this, right? So step 1, do a free body diagram to find, first we want to find the theta and the HIF, H, HI, to find the theta, HI. So then we do a tan theta equal 6 per 12, 6 per 12, 6 per 12, okay. And then we got the this one 26.57 degree. So cos theta equal to 4 per hi, this one 4 hi. Thus hi equal ij equal k, okay. I'm sorry. This is okay, and then we calculate the next alpha equal 19 degree minus theta, and then we assume theta is 26.57, and then answer is 663.43. So the beta, and then 118 negative 63.43 degree, and then minus 63.43 degree, and then beta is we answer the 53.14. So gamma got a 90 degree, and then minus 53.14, and then calculate that, answer the 36.86 degree. So the next so the alpha, the beta. So we do a H, we want to find the HJ. Okay. So we using theorem Pythagoras. So to find the hypotenuse. So we do 8 square plus 4 square. And then I got a hypotenuse 8.94 meter. And then we do a scene to find the HF. This one, we use a formula sin 26.57 degree per sin bracket 63.43 degree divide to 2 and equal to HF per 8.94 HF, so per HD. So we got answer 4.997 meter. So we assume that 5.0 meter. So after we got the HF, we want to finding the HG. This one. So HF equal to 5.0 meter. We use a sin 30, and then HG per 5. This one HF, and then HG per, equal to 2.5. Right meter. This one we got the 2.5. So we want to know x. So we do a formula this cos 60 equal and then we use a hg and then x per hg, right? X per hg, alright. So x equal to 1.25. So next, this is a free body diagram to finding force for HF. So we got the HF, we got the HG. So we want to know force HF. So the counterclockwise moment at J is 1. So we calculate that. Oh, calculate that. They move it counterclockwise. So 25k bracket 6.75 this one. And for FHF, force for HF. And because we want to find the force HF, so divide the 4 equal to 0. So we want to assume that the force is 42,187.5. So Newton meter. So the after that we want to know about FQP because the same the opposite direction. So we conclude that force QP is same with HF because they move opposite direction. We use the same moment. Next, free body diagram finding to KL and GE. So KL want to find the first theta. Find the tan theta equal to 30 per 2.7, and then we got 84.86 degree. And then second we do a tan 5.14, and then EK ke K, and then we got EK and per 6, and then we got the EK 0.54. So the first data we got the 84.86. Then we got the tan 5.14. So we want to find the value EK 0.54. So FE, we want to find FE equal to 12 minus HF minus 0.54. So HF, we got the HF 5. Before that, we had got a HF 5. So just insert that 12 negative 5 negative 0.54. We got a FE, this one a 6.46 meter, and then JE, we want to find JE. JE squared equal 5 square plus 6.46 square minus 2 divide to 5 divide 6.46 cos 53.14 degree. So JE square, and then we got the square root, and then we got the answer 5.26 meter. And then this one we do to find the theta. Right, so sin 53.14 per 5.29 equal to sin theta 6.46. So we got the first one theta. So before that we got this theta, and then 77.7, and then theta 1 equal to 77.7 minus 36.86. Right, so we got the theta 1 40.85. So the next we want to find this one theta 90 minus 40.85. I'll say that 49.15. So moment the counterclockwise MAH is 1. So negative 25 divide the 10. Okay. So divide the 1.525 minus FGE cos 40.85 degree divide 8 minus FGE sin 40.85 divide 4 equal to 0. So FGE negative 3 point no sorry negative 3 say 1250 per 8 1 per 8.667. So we got FGE. Assume that the FGE is 36. First for GE is 3605.3. Okay, and then FY equal to 0. FKJ cos 63.43 degree minus 25,000 plus 3,605. 3 cos 40.85 degree minus to 0 equal to 0 FKJ. So we assume that force for KJ is 1 is 49,795 Newton. So next we want to know about force KA. Alright, so FKJ. So tan theta 1. So, sorry. So tan theta equal to 2.5 equal to 30. So theta is 5.14. And for we want to know first for KA, Fy equal to 0 for 49,795 sin 26.57 degree plus for 9,795 sin 26.57 degree minus FKA cos 5.14 degree plus FKA cos 5.14. So we want to find the FKA. So the answer is 22,362.8 Newton. So next, the finding to DS. So we just calculate that. We know theta for we know the theta for FKJ. So next we want to know. We just use tan 5.14 equal to C1 per 6. So his answer is 0.54 meter. So next, tan 5.14, 1 per 2 sec s per 1 each 1 per 2 sec s equal to 3.24. So answer that 2.7 meter. So that's a data. We want to find this data. And then we got the 2.7 per 6. We answer is 24.23. So Fy equal to 0. 22,662.8 sin 84.86 degree minus 22,362.8 cos 5.14 degree minus FDS cos 24.23. So hence the FDS is a zero force. So the next question is to determine the magnitude of the gripping force produced when 300 Newton force are applied as shown. So this is a full free body diagram for question 2. So this is a first step. You want to know about the By. We want to know about force first. So the moment are counterclockwise, moment E. Okay, go to 0. So F bracket F divide to 0.024 minus the By divide 0.096 equal to 0. So we got the F negative part for By. So the next we want to do to find moment. We want to know about By find the value By. So Bx equal Bx divide to 24 24 divide 10 negative 3 and then plus By 12,000 12 divide 10 negative 3 and then minus 300 divide 448 divide 10 negative 3 equal to 0. So we calculate that we got the Bx, we assume that 0 force. So and then we got the By 11,200 Newton meter. So we want to know about force. Okay. for BY, so we assume that BY is 11,200. So we just input that. Answer is 44,800.
Assalamualaikum, my name is Muhammad Muhammad Saluddin. My metric number is B0922100044 from class BMMV session 2/1. Today I will presenting my part for this assignment, which is the question of number 3. The question of number 3 is the bucket of the front end loader shown carries 3000 load. The motion of the bucket is controlled by two adjacent mechanisms, only one of which is shown. Knowing that the mechanism shown supports one half of the 3000 Newton load, determine the force exerted. Number A is by cylinder CD and member AB. B is by cylinder FH and C by pin G. About diagram number 2, we saw that we have to find the force at point AB. Now we can resolve the moment to get the force at AB, point AB. The first thing we will to do is the equation of moment. We consider counterclockwise. Moment origin is positive equal to 0. 1500 40 times 10 square negative 2 equal to FAB. FAB 40 times 10 square negative 2. The answer of force at point AB is 1500 Newton. Okay, we have to find the theta first at point CD. So when we get the answer of theta, we can resolve the equation of free body diagram number 3. This is a full body diagram number 3. So tan theta equal to 0.2 divided by 0.5. The theta equal to 21.8 degree. The moment of E, considered counterclockwise, is positive equal to 0. FAB 0.6 plus FCD cos 21.8 theta. We get from there, just put in the equation of free body diagram number 3 to get the answer of force at point CD equal to FCD sine 21.8 degree times 0.1 equal to 0. 1500 times 0.6 FAB we get from free body diagram number 2. The answer of FAB 1500 times 0.6 equal to FCD sine 21.8 degree times 0.1 equal minus FCD cos 21.8 degree times 0.4. 0.371 FCD minus 0.1371 FCD equal to 1500 times 0.6 negative 0.3339 FCD equal to 900. So when we want to get the answer of FCD is 900 divided by 0.339. The answer is FCD equal to negative 2695.4 Newton. FCD equal to 2695.4 Newton. Compression at C. Okay, this is the equation of Fs. The force X consider right direction is positive equal to 0. Negative 1500 equal to Es plus 2695.4 times cos 21.8 degree equal to 0. The answer of Es is equal to negative 1002.6 Newton. Equal to 1002.6 Newton to the left direction. So become positive because we consider positive. Just direction is to the left direction. The equation of Fy, which is the force y considered upward direction is positive equal to 0. EY plus 2695.4 times sine 21.8 degree equal to 0. The answer of EY equal to negative 1000.98 Newton. This is negative, right? So we want to make the answer of EY in positive because we consider the output is positive. So the direction is become downward. So the answer of EY is positive 1000.95 Newton downward direction. This is our last question of number 3. This is a free body diagram number 4. Here we want to find the moment, we want to find the force at point FH. So we will use the moment equation. Is the moment of G consider counterclockwise is positive equal to 0. 2695.4 cos 21.8 degree times 0.05 plus 2695.4 sine 21.8 degree times 1.5 plus 1002.6 times 0.445 plus 1000.98 times 1.1 minus FFH sine 45 degree times 0.15 plus FFH cos 45 degree times 0.6 equal to 0. So we can the force at resolve to find the force at point FH. 1626.72 plus 1501.3 plus 545.17 plus 1101.08 time plus 0.106 FFH plus 0.524 FFH equal to 0. We can get 0.1318 FFH equal to negative 4680.27. So we want to get the answer of force at point FH. This answer negative 4680.27 divided by 0.318, we get the answer is negative 1400. The answer of force at point FH equal to negative 14,700 and 17.83 Newton. FFH equal to 40,700 and 17.83 Newton. Compression at F, the direction is the left direction. The answer is positive. FFH equal to 14,700 and 17.83 Newton compression. The equation of FS is the force at consider the right direction is positive equal to 0. Gx minus FFH sine 45 degree minus 1002.6 minus 2695.4 cos 21.8 degree equal to 0. The answer of Gx is equal to 3912.31 Newton. The direction is the right direction. The answer will become positive. The equation of Fy, the force y considered upward is positive equal to 0. Dy plus FFH cos 45 degree minus 1000.98 minus 2695.4 sine 21.8 degree equal to 0. The answer of Gy, we will get negative 8405.1 Newton. Dy 8405.1 -1 Newton downward because the equation is Fy. So the acting downward of Gy. Gx also same because the equation is Fx. Direction in x axis. So the direction is the right in x axis.
Hello, my name is Muhammad Irfanuddin bin Zainuddin from class BMMV 2/1 and my matrix number is B0922100009. Today I'll be presenting my part for this assignment, which is question 4 and question 5. Okay, question 4. Arm ABC is connected by pins to a collar at B and to crank CD at C. Neglecting the effect of friction, determine A, the couple M forces at B, pin B, C, pin C, D, support pin D required to hold the system in equilibrium when theta equals to 0 and 90 degree. This is the free body diagram for question 4. Okay, first step. In order to find the force Fx, you can use the equation of equilibrium, which is a sum of Fx equals to 0, considering assuming the direction to the right is positive, which is Cx minus 240. 240 is from the question given, equals to 0. Then take the negative 240 and move it to the right side, and you get Cx equals to 240 Newton. Okay, next, by using the sum of moment at point C equals to 0, assuming the rotation is counterclockwise positive. By taking the 240 Newton times by 180 times by 10 power of negative 3, which is the distance of A to B, plus 320 times by 10 power of negative 3, which is the distance from B to C, equals by By times by 160 times 10 negative 3, which is the distance of B to C horizontally. And you get the answer for By is 750 Newtons. Okay, next, by after you get the answer for By, which is 750 Newton, you can move on to find the force Cy, which by using the sum of Fy equals to 0, assuming the direction upwards is positive. Cy minus By equals to 0, replace the By with 750 Newtons, you get Cy minus 750 Newtons equals to 0. You take the 750 Newtons and move it to the right side, and you get Cy equals 750 Newtons. Okay, for the next part, which is the second FBD, also using the equation of equilibrium, the sum of Fx equals to 0, assuming the direction to the right is positive. You can take Cx minus Dx equals to 0. Simply just replace the Cx with 240 from the previous equation, and you get Dx is 240 Newtons. Also, same for the Fy, the force Y, the sum of Fy equals to 0, assuming the direction upwards is positive. Cy minus dy equals to 0, replace the Cy with 750 Newton from the previous equation, and you get 750 Newtons for dy. For the third FBD, to find the moment, you can use the sum for moment equals to 0, assuming the rotation for anti-clockwise is positive. You can place 240 Newtons from the previous equation times by 125 Newton times 10 power of negative 3, which is the direction of which is the distance from D to C, minus by 750 Newtons times by 300 times 10 power of negative 3, which is the distance from D to C horizontally. And you get 330 minus 225, and you get the answer is 195 Newton meter. Okay, for the fourth FBD, you can assume the rotation of moment at point C is counterclockwise positive. The sum of moment at point C is equals to 0. You can also do the same thing as the equation previously, which is negative 240 times by 160 times 10 power of negative 3 minus by By 160 times 10 power of negative 3 equals to 0, and you get the answer for By is 175. Assuming the direction to the right is positive, the sum of Fx equals to 0, same as to Cx equals to 0 Newtons. The sum of Fy equals to 0, assuming direction upwards is positive, which is Cy plus 350 Newton from By, and you can minus that with 240 Newtons, and you get the Cy equals to negative 135 Newton. Okay, for the FBD5, the sum of fx equals to 0, assuming the direction to the right is positive, dx equals to 0 newtons. Sum of fy equals to 0, assuming the direction upwards is positive, and you get dy equals to 135 newton. The moment, the sum of moment equals to 0, assuming the rotation counterclockwise is positive. And you replace all the equation with cx times with 125 times 10 power of negative 3 plus 135 times 300 times 10 power negative 3. Question 5. Two hydraulic cylinders control the position of the robotic arm ABC. Knowing that in the position shown the cylinder are parallel, determine the force exerted A by each cylinder, B by pin B, C at point support F when P equals to 250 newtons and Q equals to 150 newtons. This is the MPD for the question 5. Okay, step 1. By using the equation of equilibrium, the sum at moment A equals to 0, assuming the rotation counterclockwise is positive. Negative by times by 150 times 10, negative 3, which is the distance from point B to A, minus by 250 times by 750 times 10, negative 3, which is the distance from P or point C to A, equals to 0. By that, you get the answer for By equals to 1,250 newtons. Next, to find Ay, you can use the sum of Fy equals to 0, assuming the direction is upward is positive. Ay equals By plus 250. Ay equals to negative 1,250, which is from the equation before this, which is By plus B 250, and you get negative 1,000 Newton. Okay, next I want to find the force in cylinder EA or FEA. You can just 750 power of 2 plus 1,000 power of 2, and you get the answer 1,250 newtons. The next step is moment at point E, assuming the rotation counterclockwise is positive, equals to 0. Ax times by 400 times 10 negative 3 equals 1000 times by 300 times 10 negative 3, and you get the answer for Ax is 750. The sum of Fx equals to 0, assuming the direction to the right is positive. Bx equals to 150 plus Ax, and you just take 750 newtons from Ax to the moment at point E, and add it to this equation, and you get 900. For the answer for Bx is 900 newtons. For the last step, which is step 4, to find the tan theta equals to 400 divided with 300, and you get the theta equals to 53.1 degree. After that, you use the sum of Fy equals to 0, assuming the direction upwards is positive. Fy minus with 1,250, which is from By, plus with 93.75, the FGD, from FGD, sine 53.1 degree equals to 0, and you get Fy is equals to 1,175 Newton. And for Fx, assuming the direction to the right is positive, Fx equals to 0. Fx plus 93.75 from FGD, cos 53.1 degree from the theta, minus with 900 equals to 0. And you get the Fx is 843.7 Newton. And that is all for me. Thank you.